All right, so get this. Imagine reaching right into the Kotlin compiler and tweaking how your code gets turned into what the computer actually runs.
Yeah.
That's some serious power. And that's what we're diving into today, Kotlin compiler plugins.
It's kind of like having that secret decoder ring you always wanted as a kid, but for how Kotlin works.
Oh, I like that.
All those awesome libraries like Kotlin serialization, the stuff that seems like pure magic, compiler plugins are how they make it happen.
Okay, so we're not just making the compiler faster.
Hmm.
We're talking about adding completely new features, right?
Totally. Kevin Most, in his guide, Writing Your First Kotlin Compiler Plugin, he breaks it all down. And before you think this is for some, super niche developer, these plugins are why you can even use things like ulopen or those Norog annotations, everyday stuff.
Wait, those little shortcuts are thanks to compiler plugins? I use those all the time,
Yep.
but I just figured that was annotation processing.
Some overlap there for sure. And that's where Kevin's comparison table from the guide is super helpful. We'll get that up on the visualizer, but think of it this way. Annotation processing is like leaving notes on a script, right? Feedback, maybe generating a bit of extra code. But you're stuck working with just the source code. Compiler plugins, though, those are like having the editor's pen.
Ooh, I like that.
You work directly on the final product, in this case, the bytecode that the JVM, the Java Virtual Machine, actually understands.
So way more powerful, but that also means way more complex, I'm guessing.
Yeah.
I mean, messing with bytecode sounds kind of intense.
It's a trade-off. Remember Android extensions? Back when you could just access views in Android directly? No more fine view-by-eyed craziness.
So good.
That was a compiler plugin showing off. But yeah, building them. It's not a walk in the park. You're dealing with the Kotlin compiler itself, build systems, sometimes even needing to get into IntelliJ plugin development if you want to get really fancy.
This is starting to sound like the difference between baking a cake from a box and whipping up some multi-tiered masterpiece from scratch.
100%.
Both delicious, but one needs a lot more skill.
Exactly. And that masterpiece analogy, it really fits. Compiler plugins give you that fine-grained control. You can build something truly unique. Let's actually break down how powerful they can be with a real-world example you've definitely used. Kotlin serialization. Think about it. I mean, how else could you have data just magically transforming itself into, something you can store or send over a network?
It's like having a personal translator for the digital world.
Right.
You just tell Kotlin what you want, and boom, the plugin handles all those messy details behind the scenes.
That's the beauty. But before we get into how these things tick, we got to understand the structure, like the blueprint of a compiler plugin. Kevin's got this great diagram in the guide, almost like a factory assembly line. Each part plays this vital role.
Okay, so we've got our factory all set up, but how do we see what's happening on the assembly line? Kevin uses some really neat examples in the guide, right?
For sure. He's got this idea of method call tracing. That's something annotation processors just can't touch.
Okay, so before we get lost in the weeds, what's so special about method call tracing? Why can't annotations handle it?
Picture this. You're debugging some really gnarly code. So you start adding print statements, right? To see when each function runs, maybe how long it takes.
Right. Classic debugging.
Exactly. That's basically what method call tracing does. But with the compiler plugin, you can automate the whole thing. Just add a little annotation, like @debug_log, to any function you want.
So much easier than adding print statements everywhere.
Yeah.
But why can't annotation processors do this? I'm still not clear on that.
Because they're stuck working with the source code. They can add some stuff, change some stuff, but they can't really control how a function runs, deep down.
Okay.
Compiler plugins, though, they work with the compiled bytecode. Way more control.
We're back to bytecode. It's like every time we talk about the really cool stuff, bytecode is there.
Yeah.
Give us a quick refresher. What is it, and how does it play into this whole tracing thing?
Think of bytecode like the language that the JVM, the Java Virtual Machine, actually speaks. It's your Kotlin code, but way lower level.
Yeah.
A series of instructions for the JVM to follow step by step. When we mess with bytecode, we're adding our own instructions into that mix.
So we're sneaking in our own little messages for the JVM. I love it.
Exactly. And to get how those messages work, we got to talk about the JVM as a stack machine. Remember that stack of plates analogy?
Yeah. Add plates to the top, take them off the top. First in, last out.
Perfect. The JVM uses a stack like that to manage data while it's running your code. Every instruction either pushes data on, pops it off, or does something to the data that's right there on top.
Okay, I think I see where you're going with this. So to add our debug messages, we have to mess with this stack in a way that doesn't, break the original code.
Exactly. Say you have a line of code like val result at add 5 multiplied to 3.
Easy peasy, adding 5 to the product of 2 and 3.
Right. But in bytecode, that becomes a bunch of little instructions like push the number 2 onto the stack, then push the number 3, called multiply function, that pops off the 2 and 3, multiplies them, and then pushes the result, which is 6, back on. Then push the number 5, call add, it pops 5 and 6, adds them, pushes the result 11, back on. And finally, store that top value, the 11, in a variable called result.
Wow, so every little step is messing with this stack to do a bit of the calculation. It's like a choreographed dance or something, but with numbers instead of dancers.
I like that. Now, with a compiler plugin, we can sneak our logging instructions right into that dance. Like, before calling multiply, we could add an instruction to print entering multiply function, and then after, another one to print exiting.
No way. So we're basically rewriting what the JVM does, but in a way that makes the original code even better.
You got it. We can do this for any function. We just need to analyze the bytecode and figure out where to put our instructions.
Okay, but doing that manually sounds incredibly tedious.
Yeah.
How do we actually pull this off in a compiler plugin?
And this is where Kevin brings in the method visitor.
So this method visitor, it's like we have a backstage pass to the bytecode, right? We can watch every instruction happen and even slip our own in.
That is a really good way to put it. And luckily, we don't have to write the raw bytecode by hand. Kevin talks about libraries like ASM to make it all more manageable.
ASM's that like a bytecode toolkit?
You got it. It lets us talk to the bytecode at a higher level, almost like writing code instead of moving around like ones and zeros or whatever.
Phew, that's good to hear. But even with the toolkit, this still sounds like you need to really know how the JVM works deep down.
Yeah, it's definitely a different way of thinking than just writing your normal Kotlin. But that's kind of what's so cool about compiler plugins. You're not just making code that the JVM runs, you're like extending the JVM itself, adding stuff that wasn't there before.
All right, you've officially blown my mind.
Uh-huh.
So lots of bytecode talk, but Kevin also mentions this other thing, IR generation extensions. What's that all about?
That, my friend, is the future of these plugins. So bytecode, that's specific to the JVM, right? But Kotlin's becoming more platform agnostic all the time. Kotlin native, other targets, it's expanding.
True, Kotlin isn't just for server-side anymore. We're seeing it everywhere, mobile, web, even those tiny computers.
Exactly. And that's where IR comes in intermediate representation. It's this more abstract way of thinking about your Kotlin code, a kind of universal language that can be translated to different platforms.
So instead of a plugin that messes with JVM bytecode directly, I could write one that works with this IR thing, and it could theoretically work everywhere.
You got it. IR generation extensions let plugin devs hook into the compiler at this higher level, and that opens up a ton of possibilities. Imagine plugins that optimize code for specific hardware, or generate boilerplate code, or even add entirely new Kotlin features that work across platforms.
Wow, that's next level stuff.
Yeah.
It's like instead of extending one platform, we're extending Kotlin itself.
Exactly. And honestly, this is still the beginning. As more folks dive into this world, we're going to see even more amazing tools that push what Kotlin can do.
This has been awesome, really, from like those simple annotations we use every day to getting deep into bytecode, and then this whole future with IR.
It shows you how powerful and flexible Kotlin is. The fact that we can reach into the compiler and customize it like this, that's huge for developers who really want to push the limits.
For sure. So to everyone listening, if you ever thought, man, I wish Kotlin could do this one thing, or you just geek out on how compilers work, go check out Kotlin compiler plugins. Seriously, you can do some amazing things.
Who knows, maybe you'll be the one to build the next killer Kotlin feature that everyone will be using.
And that is all the time we have for today's deep dive. We'll catch you in the next one.